Good afternoon, everyone. So this is the third session of the trainings that we've been having so far. This one is related to how we can deploy the payment hub on the system. So we are just going to give you an overview of the steps. Okay, so this is the overview of the topics that you could expect. We're talking about the scope and expected outcomes from this. We're going to give you a brief rundown of the deployment models that are possible when installing a payment hub and where and when they're more useful. Then we'll be telling you a little bit about the prerequisites before you can actually think about installing the payment hub, more related to the requirements related to systems and other things. We have prepared a very small pre-installation checklist, very specific to this instance that we're talking about. We'll be talking about that. Then we're going to go into installation instructions. We'll have a brief overview of the instructions of deploying various Helm charts that we'll be talking about. And then we'll finally, before wrapping up, we'll be talking about the configurations that have to be made into the system so that the system becomes operational and functional. And finally, at the end, we'll have our summary and some questions as we go forward. So as always, this training is targeted towards the implementation teams related people who are involved in this project, technical project managers, implementation team leads and engineers, and any operations and testing teams, especially for this part. And we also expect that the audience who are going through this training have a basic understanding of the GovStack initiative. What are the requirements and requirements and implications that were there for implementation of the payment building block regarding the G2P and P2G payments and use cases. Then they would have some understanding of the Kubernetes and the containerized deployment method. And then they would have some basic understanding of the terminologies in conjunction with the payment systems and the overall GovStack initiative requirements. All right, as we just talked about it, we are on session 3 today. We've been through the introduction of the payment hub and the payment building block and the bigger picture. Then we went into a little bit more focus and talked about the technical architecture of the payment hub and how the payment building block API stacks and functionalities have been deployed over it. Today, we'll be talking about how to go ahead and implement and deploy payment hub in your premises. Basically, just to explain the scope of this also, we'll be talking about all the available commands that you have and the available files that you have and how you can use them. So this is, and we will be then left with 2 more upcoming sessions, which we'll talk about at the end of the training as well. Right? As always, before we proceed further, there are 2 terminologies that will be used quite much in the training ahead. One refers to payment hub and the other is related to payment building block. So payment hub is actually the candidate solution that has been implemented for payment building block, which consisted of the requirements that were chalked out by the payment building block working group. So whenever we mention payment hub, it is actually the solution which is made in lieu of payment building block. So the objective of this training is to equip participants with the initial understanding of the possible deployment models there are, give an overview of the basic skill in infrastructure requirements that are there for before the system could actually be installed. Apart from that, some other prerequisites related to the systems that you may need to know and the environments that you may need to set up before that. We'll give you a brief walkthrough of the installation steps so that when you go ahead and someone tries to install them, they would know what each step means and what it entails. And then at the end of it, we'll give you a brief overview of the configurations that are required to make the payment hub functional. By the end of this entire training, in a nutshell, you should be able to understand the basic requirements before setting up the system, and you should be able to understand the basic instructions that need to be executed to make the system set up and function. Coming to the deployment models that we are there. So as we've talked about previously as well, based on the core concept that the payment hub has to be independent of the payment building block, implementation has to be independent of the environment that it is running on. So there are those options. It could be run on cloud premises as well as on premises as well. So there are these options as well. Other than that, there are three different models that are possible for deployment. There is the bare-bone deployment model, there is the medium deployment model, and a fully scaled deployment model. What are these models? We'll be talking about them shortly. So bare-bone deployment model is a very simple deployment model where in just one node, everything is over there. And it is basically required for or recommended for testing out or for checking out the proof of concept, whether it's working or not, just if you are playing around with it. And then we have the middle deployment model or a medium-sized deployment model, which is what we are currently proposing to have in the basic installation steps that we'll be talking about. So this is although this can be have stretched installations across data center, but it is not recommended that much, although it comes with full functionality and it comes with fault tolerance as well. And then we also offer a fully scaled deployment model, which runs multiple real-time engines simultaneously, and it can be geographically distributed if it so requires, and it has better disaster resilience and high availability as well. So it gives a better throughput as compared to it. Of course, all of these models have their own infrastructure requirements as well, which we have shared in this slide as well, and they are written down in our documentation as well. Besides that, if someone wants to test out the implementation, we have the sandbox environment ready where people can go in and check the functionalities. All right. Just to give you an idea what we say, what we mean when we say that these are the types of models, we've given you some visual graphics over here so that you could understand. As you can see, this is very minimized model. There is no redundancy for high availability, so it is not recommended to be used in production. It is recommended if you want to test out the things. The components that come with this type of model is again all the basic functions that are required to test the functionalities. The payment engine is there, and the Kubernetes orchestration entire engine is over there. ZB for working out the BPMNs, and Kafka for queuing engine, as well as the ELK stack and all the connectors that we talked about. And there's also the storage database. So overall, in one node, everything is there, but it does not have any redundancy. So it is ideal for small scale operations. And also this is a cost-effective solution, so it is recommended when you want to test it out. Then we have the medium deployment. Again, a single Kubernetes cluster is there, and it contains all the necessary equipment. But over here, as you can see, we have some backup requirements as well. So it would give you a little bit more let's say better throughput than the single node, as well as it will give you better availability as compared to the single node. So again, all the components are there, the basic component requirements are there. So this is better for testing out pilot rollouts when you are testing out with minimum participants and you want to check how this could be better. Of course, there are options for scalability, as we've talked about previously as well. And you could go to full length, full function, which is the full scale deployment that you see over here. So full scale deployment has much better availability, lots of disaster recovery points. It has multiple real-time engines working simultaneously. So it is always available as well. You can see it over here. It has multiple independent engines which are working. So it is a full feature set, and with high availability, there is much better fault tolerance in case of disaster scenarios because it can also be geographically distributed, so you could rely on it more. Again, the components, as you can see, are all there. One thing which we need to point out over here, in all of these deployment models, all the basic components are deployed. It's the way that they are able to replicate, or the computing power that we're talking about in which they are different. Otherwise, the functionality is there for all the deployment models. So this full deployment model is suitable for situations with very high transaction loads. So if you're talking about lots of participants, lots of transactions coming in, you have to handle multiple tenants and various FSPs and have gone full-fledged now in the market there, then this is the model that is recommended to use at that time. Some of the things that we have to consider, or this is a little bit before we've come to it, but going forward, when we'll be talking about the installation and implementation, or even the deployment of the models as well, some of the things that you have to consider are that the system that you are using, what is the purpose of the system that you're using? And based upon that, you will use that particular model as well, and the deployment scenario as well. So, and you would also have to consider that some of the components, how they would be integrated together, what would be the authentication protocols, how they would communicate with each other. So these are some of the challenges that you could also face, but these are things that you have to consider as well. So, and as we'll be talking about ahead, and the deployment and integration is done through Helm charts. The updating is done through Helm charts. So even though we give you some templates and the basic ideas, but it depends upon the implementer's need that they should be customized as per requirements. So some of to put it differently, some of the challenges that we saw some of our implementers face was in identifying the specific values that had to be put instead of the ones that were given by default. So if those values are not specified, for example, the namespaces are not specified, or some of the files are not specified, then they get installed by default, and sometimes that could cause some problems with that. So if the containers fail liveness probe, then it is good to reconsider and starting increasing the initial delay seconds so that they could get sufficient time to get fired up. And also, one of the last point that we've given as a warning, it is, please do not forget to expose your operations web service port at 4200 in your environment to use it as admin UI, because that is required to access it. David, would you like to add something to it, please?
No, I think that covers it. I mean, these points we will go through and we'll hammer home as we go onto other slides as we go through the deck. But just building on the experience where it's been deployed in our own test environments, and equally the sandbox deployment, which is now up and running and then integrated into UCS use case. These are the typical gotchas, and so we just wanted to highlight them, and we'll expand these out as other implementers come on board, and if we find any other things people need to consider, frequently asked questions, we'll update those on the Git book and onto the GovStack site.
All right, we come to the next section, which is about the prerequisites to the installation and setup. So, of course, before we could actually go to the installation itself, there are some things that have to be considered. This we've also talked about in our previous sessions as well. The ingresses and the access management components and the load balancing components, these are outside of the cluster, payment hub cluster. So they are environment specific, and depending upon the implementer's requirement, they would need to be set up and have to be integrated with the payment hub instances. So we've given out a few links which could be used to further explore these options. All right. Before we proceed further, it is also important to highlight that the way the system has been designed and how it is being managed in the repository over here. So what has been done is that rather than make it something particular that this MeFOS implementation is GovStack specific, or if there is another one, what we've done is that after integrating the payment building block requirements, they've all been integrated with the main fork. So there are no forks as such, they are there right there in the main branch as well. So it brings you with certain benefits that all the features of the MeFOS Payment Hub EE that were already there are now as part of the new implementation as well. So all the access is given to all the connectors that we've talked about in detail, quite in detail in the previous sections as well. And whatever future developments are done to the Payment Hub EE, they would be there for the GovStack implementation as well, because essentially this has become now the one product, one release. All right. Some of the general requirements that are there before we could start the deployment is that, as we talked about previously, also this could be the deployment could be done either on premises or on cloud. It depends upon the requirements of the implementer. The deployment itself specifically is done through Helm charts, and we'll be talking more about them. And to know more about Helm charts and how to start up with that, we've given the link in the documentation as well that we have there. Therefore, having said that, the users who will be implementing them, the users who would be deploying the Payment Hub need to have some basic understanding of Helm charts as well, just to know which files to navigate to, what commands to follow. So all that information is also present and marked out in our documentation, the supporting documents that we've given as well. Then there should also be a cluster, Kubernetes cluster available, and there should be properly configured to deploy the instance, and there should be sufficient permissions and all the prerequisites along with it that must be present. So also to use Helm charts, it must be also installed on your local machines or the environment wherever you will be working on it on the and all the installation guide, as we've told you, is there. So also Git should be installed on your machines on the system so that you could be able to integrate it with your pipelines and start pulling code from over there. We'll be having some more prerequisites as well. We have a checklist which would be coming up soon as well. Some of the basic knowledge requirements before we start working on this is to know the fundamentals of Kubernetes. So while we all have some basic understanding, it is essential and recommended that more understanding of the workbase and how it is installed and implemented is there so that they can smoothly the process could start out. The basics of Helms also need to be known, because this is how the files will be handled by the people. So they need to know the information regarding Helm charts, because this is where all the configurations are related, all the information related to the specific components being installed is there. So some basic information of Helm charts is also required. Lastly, some information, some basic understanding of Circle CI is also required. Why? Because a Circle CI pipeline is what is used for CI/CD of the whole installation. It is in Circle CI that the pipelines are maintained for carrying out any new integrations that come in, any updates that are done to the system, and it is through these that tests for those same updates are done, and it is through this pipeline that the system is ultimately deployed to the requisite environment. So it is very important that all these fundamentals are known by the people who would be implementing this project. Continuing upon the knowledge requirements, Of course, Helm commands knowledge is also required because in our documentation as well, as you will see, several commands are written which need to be understood. However, the good thing is that because those commands we've already given you as a sample to go forward to, you could refer to their specific documentation as well and change them as required. But some basic understanding of them is required. Also, understanding of the values files within Helm charts, there are specific values files which need to be used whenever you have to update or customize a value. And this is basically where all your specific requirement related values are written or configured. So therefore, that information has to be, is also a prerequisite to deployment starting. Finally, of course, there are other requirements also related to the Helm charts and other things. However, we've just highlighted the main ones that you need to know. Also, to actually be able to configure the pipelines and or to understand them, chart dependencies need to be known as well, because this would also help you understanding the flow in which that deployment is working. Also, the environments that you may need to have up and running, and also the understanding of the processes and why those processes are running in a certain way. So understanding of the chart dependencies is also essential before you could start working on the deployment.
So
Next
I
one.
guess what we're trying to say here and just sort of bring home is it's enterprise level software. So, you know, this isn't the sort of software package you just download and install on your local PC. So if you want a successful deployment and you want an easy deployment, we recommend using a DevOps engineer to deploy it. And we have seen, you know, when people that are DevOps engineers, you know, people within the sandbox team, for example, deploy it, they deploy it very smoothly. Now, you know, they may have a few questions just around specifics, which, you know, we're covering off now in the notes and the frequently asked questions. But in general, the deployment is smooth. When we've tried to having people that are not DevOps engineers, then actually the questions we tend to receive back are more general questions about how do you use Helm, how do you use you know, sort of Circle CI, etc. So that's why we just want to position it at the front that, you know, any implementer should be, you know, considering either having or getting a DevOps engineer for this stage to make it smooth and therefore reliable moving forwards.
All right. Thank you, David. So moving on, we've written down some of the system related requirements related to sizing and all those things. Over here on the left side, what you see is the minimum system requirements, the least that you may need. However, in the middle and towards right, these are the requirements that are recommended. Of course, these are basically sized upon the minimal deployment model that which we have in our samples right now. But depending upon your requirement, if let's say you're going full scale or if you have other requirements, these sizing options may increase. So this is the recommendations. And on the right side, you see the minimum system requirements for deploying the G2P sandbox chart. So these are over here. And again, the components that you see over here for which we've sized are the main components that are required for the full functioning of the payment hub. All right. Just before we proceed further, we just wanted to make a note that the payment hub is supported on Kubernetes clusters. So it is essentially environment agnostic. However, because GovStack implementation is mostly the environment of choice for GovStack is AWS. So the samples and the examples that we'll be quoting ahead would be based on AWS, but it could also be done on Azure requirements. And for that, we have specific documentation mentioned, which could be used. All right. So previously we were talking about the prerequisites related to the knowledge requirements and the system requirements. Now we'll just talk briefly about the checklist before now you're about to get ready with the installation. So some of these things you have to keep in mind. So for example, as I just told you that we are considering AWS over here because that is where the curve stack implementations are working mostly. So before you could actually start working on it, it's important that you have an AWS account created. The implementers have the AWS account created with appropriate permissions where they could create and manage the Kubernetes clusters. And having said that, it also means that a Kubernetes cluster is already configured on AWS because that is on which the whole setup is dependent. Then, of course, IAM, the access management roles are defined. This again circles back to what we talked about initially when we were talking about Kong and Nginx and Keycloak being outside of the environment because it depends upon the deployment environment. So it is recommended that all those roles are already configured and decided based upon the implementer's requirement. Besides that, AWS CLI and kubectl are configured on the local machine so that they could understand and handle the commands that are coming in. We also need, as we previously pointed out as well, Helm needs to be installed on the local machine as well for it to be work. And then we also need Docker Hub or ECR or any registry where your container images are being stored so that you could pull from them. And finally, you need a Circle CI account. The good thing about Circle CI is that you do not need to actually install it on your system. You could just create an account and pull the commands directly from the browser. So, but you need an account to be created on it, and then you have to integrate your GitHub or any repository where you're keeping the code with it. So it gives you a lot of leeway into how, from where you want to pull out the code and which system you want to use. So these are just some of the steps that you have to follow. All right. Before we proceed further and delve into the Helm charts and the Helm commands further, just giving a snapshot of the Circle CI file, which we talked about previously also. So over here, what you see is when we'll be talking about it ahead as well, we'll look into it as well. So all the deployment updates, the initial deployment, any changes, the tests that have to be done are here in this Circle CI pipeline. And all of that information is stored in this config file. Besides that, this is the main, you could say, the brain behind the installation. This file, once it is triggered and once this pipeline is triggered, it will invoke all these different files that we have and install them as per the guidelines given over here. So we'll look at them in detail going forward. So as I just pointed out, even though the actual commands and that are related to the deployment of the payment hub, the actual components are there within the Helm charts, but it is actually the Circle CI file that tells your system which steps to follow, what sequence to follow to actually execute those Helm charts. So this is important that we understand the config YML file of the Circle CI file, and we'll be going to it. I'll just, after this, I'm going to show you that as well. And as I was talking about this previously, we have different various pipelines set up for this. This is just a snapshot to give you an example how the Circle CI file actually manages the deployment. This is a deployment step. There are also the building step and the testing step, but this is the actual deployment step. So you could see over here, this is telling you that the TLS secret has to be created, then it has to build, and then it has to build and push the image. Once this is done, it calls the Docker images and so on and so forth. So it lays down the entire sequence for deploying this particular branch. And similarly, if let's say an update had been made, then the Circle CI branch, the integration branch would have been invoked based upon its own trigger, and that would have been carried out. Just to give you an idea, because it keeps changing, it's again just a snapshot of all the pipelines that are working. For example, one you can see here, these are the failed one. This is some pipeline that is right now in the process This is not a live snapshot, just to give you an idea. This gives you the success status once it has been successfully deployed. So this is basically how the system before your system is actually installed. These are the steps that are happening before you can start actually working on the payment hub. Also, these are the steps that you would be using if you update your system later on. If you push some updates, you customize it, or you have to make any changes to it. All right, before we come to the installation instructions, I want to take you through the. So this is the Circle CI file that I was talking about. I just opened this up because the commands that we'll be talking about, I can show you these better over here. But before we go into that, this is the Circle CI file. And in the steps about installation that we'll be talking about shortly, we would be referring to the PHE environment template. We have two types of files that we'll be talking about. One, this is the template, which is recommended for first time implementation, first time if you're installing the file for the first time. It is recommended that you go through this file. Otherwise, we also have an alternate file for where if you want to deploy from scratch, you could use that file. But just to give you an idea of the structure, this is the Circle CI file. This is the config YML file that we talked about. This includes all the information that that is required for integration and deployment or the entire CI/CD cycle. So what you see over here is if I click on this config YML file, you see some orbs, which orbs refers to it. This is what gives you the reusability that we talk about. If already the configurations have been done, you can use these uh, files again, and you could call them and you can deploy using these files, run these commands again. Then the Circle CI file also includes the config file, includes jobs. What this basically refers to the different tasks that have to be performed in when we were talking about the pipeline that we showed. So the pipeline would refer to these jobs, what tasks have to be done. It tells the environment from where the Docker images have to be pulled. It gives the idea. It tells about which repository to use. Then it tells about which environment it has to use. The steps that we are talking about here are the one by one step that has to be followed to perform this job overall. So, for example, what you see over here is this is one job, then this is another job. This right now in jobs, what it does is simply laying out all the functions that this config file or this pipeline, this specific file would be carrying out. And it includes all the details of it. Once it has described all the jobs, it also, we have lots of these jobs, all the things that have to be done. It then also describes the workflows. Let me find them, workflows. Yeah. So we've defined all the jobs upwards and down. And when we come to it, we define the workflows. So the workflows is actually the sequence that would be followed when we are actually implementing or deploying this file. It again tells that which jobs have to be performed in which sequence. So when I write workflows and then I write down jobs, this would be the sequence that would be followed over here and the context that is required. What does it require? For example, just to give you a quick idea, for example, if I have to build and host G2P sandbox, this would require that I've built and host engine has been run previously. So this is dependent upon that. It gives you that idea as well. We also have in this file, let me show you. Good thing is it also lays down the dependencies. Okay. Maybe not in this file, but it also lists down the dependencies that are there. For example, because this may be an old version. I just wanted to show you, but I'll get to it later, which lists down the requirements that are there for requirements related to the environment requirements that are there to run this whole file. So what you saw over here is that once this file has been triggered, what it happens is if it's running a job, for example, it is going to run the host, build and host G2P sandbox environment or build and host engine. It would call one of these other files, it would access them and then deploy them as per the requirement. So we'll come back to this later. Just wanted to give you an idea before we went to the commands. All right, installation instructions. So just to make it clear, all of these instructions that we show you over here are also present in our documentations, and you could refer to them going forward. So this is a very, very quick version that is over here, how to call the repo and how to use the Helm install chart. And this is the command that has been given to quickly deploy the sandbox version right now. One thing which we have to point out over here is that by default, once this deployment has been done, the Helm charts have been written through which the post-deployment steps are carried out automatically. However, it is also possible to carry them out manually, but just to let you know. So we've given this command over here for quick version. Now going forward to explain the process one by one. So as we were talking about previously as well, now you have your system set up, you have Kubernetes set up, you have your GitHub integrated with your Circle CI files, and the system is up there. Now there are two options for you. We have two type of GitHub repositories. You could either use the environment template and you to start building with from scratch, or you could use some of the sample environments that we have given you. So this is basically, it depends upon your requirement, which you want to use. This file over here, one is the one I was just showing you. This is the template one. However, there is also the environment labs file where you want to test around on your own. So once the file have been, the command has been given and the installation has started, the Helm charts would be deploying, installing all of these components. And these, I'll show you in the Helm charts as well, where we have it. Let me try to get this over here. Come to Helm charts. Over here. This is the environment template. So we have in our Helm charts different components that will be, oh sorry, this is here. I just wanted to show you. So when we call that command, these are all the components that would be deployed by default. As you can see over here, let me make it. This is, sorry, I wanted to put it up side by side so you could see. We can see the connectors, all the list of connectors that would be deployed over here. The main connectors, you can see the bill pay, the bulk payments, channels, other channels, GSMA channels, the M-Pesa, the bulk, all these connectors would be also be deployed, the operations app and the services related to Elasticsearch. These all will be deployed. The vouchers you can see over here, ZB, the orchestrating engine, as well as other setup files would be, they are all contained within this Helm chart, which is the Payment Hub EE. I will show you this one, Payment Hub EE engine. So once this is deployed, this would be automatically deploying all of these. Now, I've also over here, once this file is being deployed, it pulls the images from this hub. So this is from where all the images are pulled by the Helm chart. You can see it over here. And that's why it is also recommended that you already have an account on the Docker Hub so that you can see where the images are being updated, where it is coming from. All of these are public. All right. So what it is essentially doing is, because of this one file, and in fact going more in granular level, the Helm chart actually packaged all of this complexity of being having to install all of these connectors and all of these components one by one. They were all packaged into one folder, and once that command was fired up, when it was triggered, it automatically started to deploy all of these one by one. So it makes it very easy, convenient to set up, and to also to ensure that when we are deploying these, it is a standard deployment. And it is also that all the things that are required for it to run are already there. All right. So this is we are gives you just a brief overview, a walkthrough of actually carrying out that Helm chart command, so that we could go ahead with it. So for first deployment, again, as we said, it is preferred that lab environments are used. The template one is used, so that because it's already configured, and then you could customize the values therein. Just to give an example of what this is, so clone the lab repository, and again, just to before we proceed further, as an overview, it is recommended that if you are running it for the first time, you clone the repository in your environment and then you run it. So you clone the lab repository and change its directory to wherever it is in your own system. Then you execute this command. So again, that's why we recommended that some DevOps person is part of this process, or that you have some understanding of the Helm command. So it says install and the release name and the namespace. So it's very important that you give the release name that is there, and also identify specific namespace, because if you do not do that, then it would be installed in the default space by excuse me, by default. So again, the release name depends upon you, whatever you choose it to be, based upon your requirement, you change it. So just to give you an idea of this command, this is the lab repository that we talked about, this file that I've just showed you as well. You have to change the directory, this part, so that it reflects where it is installed within your system. Also, you have to ensure that when you're deploying it, you have the latest version. This is again a sample. This over here represents the version. So you have to check which version you're releasing, and you can have the name as per your requirement. And as I told you, if it's not specified, then Helm will install and execute in the default namespace. So coming forward, the next step would be, we have various commands as we're talking about, as we talked about previously. So you could also update the Helm chart. You could also uninstall a Helm chart as per your requirement. So just to give you an example, this is the command that you see over here for changing or updating some configuration parameters within the Helm chart. So Helm upgrade is that command, and it tells the name of the chart that has to be updated, the release name for which it has to be updated. So this values file, and I'll show you this just after this quickly so that you understand it. This values file is where all the values for those particular configurations are kept. So this is, you could say, the backbone of what makes your system yours. It customizes it, and the namespace in which these upgrades have to be made. So this is the command for updating. We'll talk about this big one afterwards. Also, if you have to, let's say, delete or remove, and then this is the uninstall command from Helm chart that will remove that specific Helm chart as per your requirement. Then if you have to, when we talked about this upgrading command, just to give you a breakdown of what each part of this command means. And upgrade, this is the command, Helm chart command that we are talking about. This specifies the chart that you have to use for upgrading or installation. So this part particularly specifies the chart that you will use for upgrading or installation. This part specifies the values file this file have to be updated by the values in the values YML file. This specifies the name of your release. It could be as per your requirement. And this, where you write down, as we said, you have to specify the directory within your system where all of these files are kept. And at the end of this command, you also see this install. Again, because some of these commands, there are various ways to write down the commands, but this is added as an extra redundancy, that in case if the Helm is not already installed, this chart is not already installed in your system, this command would ensure that after running this command, that Helm chart is also installed in your system. And also, if the namespace is not already created, but it is recommended that you do create a specific namespace, this command over here, create namespace, would create that command. This is again a redundancy check, good to have. And once you write create namespace, you give the namespace in which you want this updates to be installed, or which we have over here as payment hub. So I wanted to take you to the values YML file just to give you an idea. For example, we come to connectable. For every file, every chart that we have, we would have a values YML file, which would contain the configuration information. So it is in this file that you go ahead and try to set the limits. For example, if I want to create some DFSP IDs and I want to specify them, I could give their limits, I could define the CPU, I could change their names if I want to change any sort of configurations. So for every Helm chart, you would see there are values YML files which can be used to configure new values or set new limits for them. So this is what we have, what we've talked about, which could be updated or changed as per requirements. So now, as we've seen that the system has been installed and is present on the system, the next thing are the post-installation operations. As we've already told you that they are automated, but they could also be carried out manually as well. But the automated operations that do occur are after, and again, these are already contained within the Helm charts. So what it does, it creates secrets for Elasticsearch, it creates secrets for Kibana, and it uploads the BPMN. So once the BPMN is uploaded, we'll also look at it briefly how the BPMN could be configured themselves as well. So these are the things that happen once the deployment has occurred initially. So also, besides that, because if you want to do that whole process manually, these are the commands that are available for you. These are the links that are available for you. So just to give you some idea. Again, as we were talking about, because it makes it easy, within the Helm chart, the post-deployment job, we have this another Helm chart which says the Elasticsearch secret, and it lists down all the processes that have to be carried out for this. So it includes all the information that is required for creating the ES secret, Elasticsearch secret. Similarly, we have a file for creating Kibana secret. We have this Helm chart over here. And for example, creating bulk processor secret or circles CI steps, we have these over here. All right. For this command over here, it shows, this link shows over here that the bulk processor secret would be invoked through the config YML file. And then because circles CI file contains lots of information that is there and includes the sequences. And finally, it uploads the BPMN that are required for carrying out the functionalities of the payment hub. All right. We were just talking about it. So commands to run tests for a release. Some of the other post-installation jobs that have to be done, this is the command if you want to test whether the release is working fine or not. you write Helm test and it with the release name as the input so that you can test whether the release has been successfully implemented or not. This is an example again. Release name is the name of your file and you give the namespace and tell where it is located. This is a sample command that you see over here. So for example, have test G2P sandbox. You are trying to check G2P sandbox and you're testing specifically sandbox test gov namespaces payment hub in the payment hubs folder. And once you run this test, you can also store it the test results either on the Circle CI containers itself or locally as per your requirements. uh, as we were already talking about previously also, we have already set up some sample pipelines as well. I showed you a snapshot just now. I'll show you another one also. So you could use those sample pipelines and deploy them at your end to run the commands. You could also update them or upgrade them or customize them as per the requirements. So it depends upon implementers' requirement, which pipeline or how they want to deploy it. All right, again, because we're focusing on very specific example of AWS over here, so this is just a representation of what secrets would have to be created. For example, for AWS, the account ID would have to be created so that it uniquely identifies the AWS account. Access key ID would be to make programmatic calls through AWS and to use AWS command line interface, because all of these commands that we are running, if we are talking about through AWS, then you need to access them. Then besides that, you would also need to identify the user or account. So a secret would have to be made for that. Namespace has to be also, a secret for namespace also has to be created so that it could identify exactly where your excuse me, charts are related, and the region in which the AWS keys are configured, you have to identify that as well. For Helm itself, you have to create a certificate file so that whenever the calls are coming, the certificates are exchanged just to ensure the security. One point which we want to highlight over here is that these are these secrets and this security is trying to match with the essential requirements that there are. So they have taken, they've tried to match with the requirements that are there. All right. So there are lots of samples available. We also have a cookbook available, and these are mentioned on in our documentation. But just to give you some idea that you could use and customize the cookbooks that are available, and there are various options for that. So let's say if you want to deploy a payment hub along with the G2P and P2G use cases, this is the location to which from which to pull that. Again, there are three options for that. You could use an unreleased or developer version. You could extend an unreleased or developer version, or you could extend the released version and then use it. It depends upon your requirements. So if you want to if you want to deploy using unreleased charts, this is just an overview of how to do that. Again, we are referring to this file. If let's say we have an unreleased version, one thing to note for an unreleased version is that it would have 0.0.0 as its version number. You clone this at your system, then in the master branch, this command. All right. And then what you do is then you have to update all the dependencies to prepare the chart. Okay, as I was talking about the dependencies previously also, because this is an unreleased version and you want to customize it as per your requirements, you would have to update all the dependencies to match the requirements at your system's end. Once you have done that, you again could have two options. You could deploy it directly, and you could package it and upload to a repo for public access. It depends upon your requirement. So how you would prepare that shell command? Okay. Uh, if you recall, we talked about the orbs in the beginning. So once this chart is prepared, after that it becomes an orbs and you could reuse it as per your requirement in the future as well. So it makes it easy that next time you don't have to go ahead and update all the dependencies or change things again. You could just prepare it and reuse it and call it in your config file as per requirements. So this is the command that you use for preparing the chart. You call this file environment template, which we are talking about, and then you deploy it in the Helm G2P sandbox, you package it, and then you put it in the repo index. And then you could install it, as we talked about previously. You use the Helm install command and install this G2P sandbox Helm in this directory, in the sandbox directory, in the folder payment hub. And you could share the file or store it in using the index.yaml at this location. There are also the second option where you could extend the developer version or the unreleased version, you could extend it. So again, we have, let's say, developer version 0.0.0 because it is unreleased. The configurations are written with the values in this file. So the values.yaml file that we just saw, you could overwrite the configurations over here so that you could actually extending the functionality to what you want. The updated configurations are then added to the base chart. So once you've updated the values over here in your values file, here, once you update the values that you have to customize over here using the command, using the update command, it will update them in the base chart in the version that you had previously installed. We'll go through this command to get an understanding of it. So then you add the dependency of the G2P chart, which is required. You add that over here. So dependencies, for example, over here, you could say that this is the dependency. It is on the G2P sandbox. It is located in this repository. And this you add to your file that you're trying to upgrade. And then you create custom secrets and ingresses can be added by, again, updating the fields in this file. So in the values file is where all the specific configuration related information is there. So you could update them as per your requirements. And all of these files, all of these commands, when they are updated through the single command, they could be committed to the version that already exists, and these will be pulled. So when you run that command for upgrade, which we talked about previously, I'll just quickly show you so that we can relate with this. When you do this, for example, this will call this chart from this specific release and will call the up values file and update it into the base chart so that now once it's installed, you would have the new values over there. Then finally, we have the another option. This is the same as the other method, except here the version for G2P sandbox chart will be a released version instead of 0.0.0. So this is the third option that we were talking about. Previously, we were just talking about reusing the unreleased version. Now, if there is already a released version, then it could also be used. It could be extended to upgrade as per requirement. Just thing that you have to note from previously is that in this file over here, we can see that there is a release version and the G2P sandbox version is also being used over here. And once that has been upgraded, it will be uploaded to the Artifact Hub for direct access later on. So you could just call it in your future commands as well. We have given some instructions on how you could install those cookbooks. Again, we have, depends upon your requirements, depending upon the chart being installed. you could install them either in the environment labs directory or in the environment templates directory. We have specific commands for deploying them, for deploying the backend installation as well as for front-end installations. So first you have to build the chart dependency. You have to highlight what are the requirements before the chart could actually be utilized. Then you install, once you've defined the dependencies in this chart over here. And to write down the dependencies, let me see if I can figure one out. We have the requirements. In some versions of the Circle CI, the dependencies are also written as the requirements. So in the older versions as well. So just to make that clear, let me see one more time and try. All right, I'm just showing this over here. Like for example, over here, we have this. So it is just showing this. So we have it specifically outlined as well. All right. We then, once we have defined the dependencies, then we install the Helm charts. Then we install the Elastic secrets. Although as we told previously, they could be automatically deployed as well, but we have commands for making the Elastic secret as well. And then we also install the Kibana secrets using the commands make Kibana secrets. Once this backend has been installed, then front-end installations could be done. The main steps are saying you have to build the chart dependencies. You use the build the chart dependencies, and then you install the temp chart so that the front end is also installed and you have the cookbooks ready. Similarly, if you want to connect to external RDBMS, depending upon your requirement, you may have already have an existing one. What you have to do is you again have to go. So the whole game over here is related to the values YAML file, because this is what includes all the configurations that we are talking about. So you open the values.yml files in the backend chart. In any of your code editor, it could be VC code, wherever you are working on it, and then you replace these specific parameters with your existing parameters. So for example, we've highlighted these over here. These are just an example that like this, there would be other parameters as well, which you would need to update, because the ones that are there in our documentations, these are just sample values, or if given for the sake of giving an example. So you would update the user, the password, and the host name with what is your system's user password and host name. And then similarly, you will replace all other occurrences of data source with external RDBMS. For example, details related to importer, RDBMS, message gateways, and wherever that RDBMS is being called, you will update it accordingly. So this is just a snapshot of how you could do that. And basically what you're doing is, so far, once you've installed it, then if you want to make that system your own or match it to your requirements, you could do that using the various Helm chart commands. Excuse me. Now we come to configurations. Before we go into configurations, it is important to note over here that when we say configurations, we mean some of the operational or functional requirements for the system. So for the system to be able to work on some data, those have to be configured in the system. Before I proceed forward, David, would you please like to comment on the main elements that you can configure once the system is installed?
Yeah, certainly. So as we say, and we'll look through it in a minute, default values exist for all of these. So if you're just playing in as your own environment and testing, you can always choose to use the default values that exist. But when you start moving into production, obviously this is where you are going to set up the fundamentals of how your system operates, especially when we're looking at it from a GovStack perspective. So the DFSP IDs would be which DFSPs you're talking to. So we can install DFSPs as part of the whole installation, and you'll typically see them called African animals like gorilla, lion, etc. However, if you were building this in reality, you might actually have your own central bank DFSIP ID that you might want to put in there. So that's where you'd need to tailor it to the specific DFSPs you're connecting to directly. Registering institution ID with budget account is very important for GovStack. So this is where you would set the financial account associated with the institution ID. And this is the only place you set it within the settings. So it needs to be set in the configuration. Otherwise, it will not be able to go back to the budget account to be able to request the funds for like G2P bulk disbursement. Again, program IDs are set up at a configuration level. So this is where you'd enter all the different program IDs that the registration building block may send across. So that it understands these are valid programs and it doesn't reject it later on. As I say, the default ID it will install is 123, but obviously you may have many different program IDs because you may be running many different G2P bulk disbursement programs. And again, tenant IDs, we support a multi-tenanted environment. So again, you need to set those tenant IDs to the specific tenants you want to do. This again, in turn, impacts when you're going through like operations web, the UI, the admin UI. Those tenant IDs are the tenant IDs you would then look to when you're making a bulk disbursement or anything else, or you want to see those transaction flows going through. So these are some of the important steps you need to do once you want to move away from, the standard programs of, social welfare, the standard IDs of 123, the standard tenants of Gorilla, Riot, No, Lion, etc., that we install as standard.
David, for the sake of clarity, could you please also elaborate on what we mean when we say multi-tenanted, so that going forward people could be able to understand when we say configurations?
Yeah, certainly. So if you assume we're installing this as a fundamental building block within a government, you may want to have different instances or different tenants, different installs of it for different government departments. So, for example, you might have a health tenant. You might have a tenant specific to, work and pensions. You might have a tenant specific to, government departments associated with construction, etc. So this is why you'd want it. It allows you to have some segregation that all flows through, again, as we say, to the UI. So if you are using that admin UI to be able to see transactions, you can limit through RBAC the permissions of the users to only look at specific tenants as well. So it's a way of setting it up in a common infrastructure, but with sort of isolated boundaries to be able to do it.
Great, thank you. So we come ahead and talk about configurations. So before we go to the actual samples, this is again just a visual representation of what we've been talking about so far. So when we will be talking about configurations, again, it is essential that we talk about the values filed over here, which we've been talking about. What happens is, and this is actually giving you an idea of how the configurations or the overall values that are given work. So we have the Elm chart, and then we have the values filed within those Elm chart. What they do is Elm chart includes all the basic commands that are there, and the commands pick up the values from the values YML file. Then together, the Helm chart is able to put them together and commit them to the Kubernetes cluster so that it can give you the latest values or the required values, so to speak. So this is just a summary of what we've been talking about so far, and it would reflect in the commands that we'll be talking about. So we were just talking about registering institution ID with a budget account. We could, excuse me. So the registering institution ID is a dynamic field in the ID account mapper. And it is populated in database when passed as part of a create and update API headers. So we will, when we will in our upcoming session, we'll also be looking at the specific APIs and their inputs and outputs. We'll be looking at this parameter in more detail. But for now, this is an essential part of the ID account mapper because it identifies the institution for which a beneficiary has been registered. So what we want is that this registering institution is given a specific ID along with the budget account, along with that account where it has provisioned the funds for carrying out bulk transactions as well as the voucher redemption or the voucher creation as well. So default value for this field in bulk processor is social welfare. But you could update it if you require. So I will show you. Just click on this. So over here, what you see is within another chart, we have this application YAML file. Over here, we have the registration institution. And over here, this is the ID that has been this. Again, as we talked about the default values, for example, the default value is the sample value social welfare. Then it is given, this is the ID through which this particular registering institution would be identified. And the name that is given to it is social welfare, and the identifier type is account. So for example, you could see, if you recall from our earlier discussions in identity account mapper, we need to also define the resource or the for example, this is the case for the payer right now, but like, for example, similarly for the payee as well, we have to identify where they would be ultimately receiving the funds. So similarly, over here, this identifies that ahead for this particular registration institute, for this value, this is an account type that has been given, an account number has been given ahead for it. So this over here includes the budget account information.
And I think the important thing you can probably see here on this representation is you can have multiple registering institutions, and each registering institution can actually have multiple programs, and they would each have a budget account. So you could easily say, there is a budget account for wages, there's a budget account for, maternity benefits, there's a budget account for, many different programs. We set one up as default, but actually in reality, when you're setting this up as, a GovStack building block, you would have multiple registration institutions, you'd probably have multiple programs. And this is where you'd go and update the configuration as you wanted a new program to be done, and push the update out to Helm to the system.
Yes. And also you could see over here the multiple payment modes that are available. So all of this information is right here in this Helm chart of source resources within the circle CI file, the pipeline that we're talking about. All right. We come back to this over here. We also have a specific test case over here, but I'm not sure if it would be running right now, or I could access it with just. So again, because all of this has been documented in several spaces, but we have tried to club it together and put this over here in this particular presentation so that you could easily access them. This is the test that has been written. Again, because we are talking about the making everything packaged together and easy to access, you could again see that within the resource Helm chart, we have this batch demo CSV is the file, the test case that would be run for it.
We'll go through these in a bit more detail tomorrow, but you can see they're written as Cucumber test cases, which if you refer back to what we talked earlier, we talked about the test cases all being written to be executed by Cucumber. And I think, those that have been involved in the test sign-off and the test cases within GovStack for this implementation as well, each of these maps to those test cases that you've seen. So you can rerun those test cases within your own environment if you wanted to.
Yes. An important thing also is this, then while we are at it, we could just quickly come to this. and see that because we have all of these test cases over here, we could have these in the flow. Sorry. Workflows. So we would have the build, once they have been built and deployed, we could have the tested out as well. So anytime there is a new test case or any updates are made to the test cases over there, and it triggers the pipeline, they would automatically be tested out and the whole pipeline would be executed once again. So we can see the simplicity of putting all of these in this config YML file over here. All right. Again, this is again the similar process for setting up a program ID, for example. So as we just talked about, just David told you that single registration institution ID could have multiple program IDs as well. Why? Because one institution, for example, a health ministry, could be carrying out multiple programs. So it could configure multiple program IDs. And one uh, program ID can have only single type of budget account ID for payer debit. So that, but one relationship that has to be maintained is that for that particular program ID, there's only one budget account associated with it, so that there is no confusion and sufficient funds are provisioned in that budget account, so that once the transaction actually happens, and if you recall, the bulk processor sends out a call to verify whether there are enough funds over there, even for voucher creation, it checks whether there are enough funds provisioned in the budget account. This call is made to over here. Configure program ID, I'll just show you again for an example because it is much better if we look at the example. This we come back to again, budget account. This is the program ID, and we see the program ID and the name that is given to it. All right. And I give you another, show you another example where we override the program ID in the setup of registering institution ID. Just to give you, okay, this would take some time. While it is opening, we'll go ahead. So when we talk about setting up tenants, so tenant is a multi-valued field configured in many services like operations app, bulk processes we talked about, because there may be multiple tenants and talking to multiple services. So one tenant could be talking to all the services that they may be required, because for example, one tenant would also need to maybe configured to not just do bulk payments, but they would also be generating vouchers. They may also be registered for carrying out bill inquiries and such. So they are required across the board. All right. So for example, we have one example over here. To test for a minimal mock fund transfer flow strategy, check the tenant configured as this. Again, as David just told you, we have given you some default values, for example, but if you want to change them to your production ready requirements, you could change them using the files over. This is just a basic test setup. For example, you can see that we have a tenant named Rhino over here. Similarly, we have various tenants as well. We have Gorilla and multiple tenants. Again, these are just sample values, but using the values YML file under the global variable declaration, you could change them. Let me go to this file and see, we can come to the global variables. We can locate them. Otherwise, we'll point them out to you later so that you could see. Anyways, the main thing over here is that when we are declaring the variables, you go to the global variables file in the values YML file and update them from over here. All right. And finally, we come to setting up of the DFSP IDs. The setting up the DFSP IDs process is almost the same as when we are setting up IDs for other parameters as well, because we want to identify different DFSPs because at one time, the system would be talking to multiple DFSPs. requests may be coming from other building blocks, from other registration institutions, and they may be outgoing to different DFSPs. So we have to set up those IDs so that we can identify. So over here, we can see, we can go to the config file in the application properties and override the values. DFSP ID, again, DFSP ID is a unique value like we talked about previously for the registration institution and for the program ID with a service generic channel connector like this. So I see if we can access this. We have DFSP IDs in the app, in the resources file, in the meta information. So whenever this information is being called, this would be able to easily identify the DFSPs that are there. This is present in the application.yml file. All right. Okay, while we're talking about this, we also wanted to point out a little bit that when we talked about that once the installation has been done, after installation, BPMNs are also uploaded. If you recall from our previous sessions, it is ZB is a very important component, one of the main engines of the payment hub, and it works based on the BPMNs that are configured over there. So the BPMN themselves, we have the capability to configure them and change them. And this is just an example that has been laid out, that how the BPMN itself could also be used to configure or update the DFSP IDs or to configure multiple BPMNs. But we just wanted to give you an idea of how the BPMNs, right? This is very small. I'll try to So this is just a sample BPMN and how ZB is being used to make them. For example, just to give you an idea of how they could be configured, when we start over here, you could see multiple tasks that could be done. You could see that this particular BPMN starts a task as a hello task, and then over here it waits for a response for a certain time. This over here, you could see that it is time bound. So if a response does not come back within certain time, it will abandon the process and start from again. But if a response comes, then it proceeds and it will go to the next step, next sequence, and it will start hello checker, whatever the process may be. Then you over here, you see a ZOR character, which means that either of these processes could only occur. Based on this outcome, either of these processes would be fired up. So and again, just to show the, let's say, comprehensiveness or the capability of the BPMN, one of this is a condition-based sequence, and another one is a non-condition based. So for example, let's say based on this process, whatever occurs, a condition is met. Let's say the condition is that the payment has to be made to a mobile money account, and it verifies that the mobile money is right. Then this further step would go to this hello condition step, and this would be carried out, working on going to its particular next steps. And why we are showing this over here is because this ties up with our with the previous session where we talked about the importance of the transaction orchestration that ZB is doing. So it gives you this capability. We have our whole documentation around it, how ZB could be installed and how in a test environment you could check out its commands and see how those BPMNs could be updated or configured going forward. So over here is just all of this is a little bit overwhelming, but this is related to the language of ZB. And once you go deeper into it, we've given out the resources through which you could access the documentation and try to understand what is happening over here. Right now, this command is actually trying to configure multiple tenants through a BPMN. So you could see over here that they've described an array of tenants, gorilla, lion, and rhino. and then written down the commands for it, what they have to do. They have to update them and create them. So this is it. Uh, Lastly, coming to the sandbox integration, we've talked about previously also, so there are multiple versions, but right now the latest version of Payment Hub EE is the version 1.13.0, and it contains the G2P functionality as well as P2G API and the operations app, which is live now. So you could also go there and get an understanding and a feeling of how the Payment Hub is actually working before actually coming to the deployment itself, just to understand the overall environment. And finally, coming to the end of the session, a summary. What we did throughout the session was actually try to give you an idea that before we talk about actually deploying the Payment Hub itself, what would be the prerequisites for it? And even before that, the main decision that the implementers would have to make is upon the type of model that they want to deploy. So based on your requirements, and based upon the resources available to you, you first have to pick up a deployment model. Once you've done that, you need to have specific skill set and people and resources available who would be able to understand those requirements and have basic knowledge, or at least functional knowledge, of the outlined system. For example, Kubernetes, Helm charts, Circle CI, the basics of running a CI/CD pipelines and all those things. Then besides that, we also had a look at specific Circle CI file, how its config.yml file packages everything, the entire pipeline, into one file, and then calls different various Helm charts to implement the system or to run based upon those defined workflows. Then we also looked at some very basic commands for Helm charts used to deploy the Helm charts, to upgrade them, to uninstall them. We also talked briefly about the post-deployment steps, which actually occur autonomously as well, but you could also carry them out manually. And some of those post-deployment steps that are worth considering are creating creating secrets for Elasticsearch, creating secrets for Kibana, uploading the BPMN, and so forth. We also looked at how you could integrate an external RDBMS with your system through the upgrades and the Helm charts that are available and the commands that are there. We also talked about several cookbooks being available for you to use, and how they could be installed and upgraded as per or extended as per the requirements, and from which versions. Either they could be installed through unreleased versions or through released versions as well. Then we briefly talked about the possible parameters that could be configured so as to make the Payment Hub functional. We just looked at the main ones, and we looked where in the repository they are placed and how we could access them, and the tests that are there to for checking out the functionality of those parameters. That's it. This is for today. The upcoming session would be on the testing the Payment Hub implementation. So what we are in the sequence that we've been going through, we assume that now that we have the system almost deployed, ready to be deployed, and once it's there, we want to check whether the system is running perfectly. So when we talked about the test cases, over here, we just talked about them in the passing, and they are just one aspect of it. In tomorrow's call, in the upcoming next session, what we plan to do is pick up a use case, run through it, say that this is what the use case would do, this is the expected outcome. And because of that outcome, what features have been fired up, which APIs have been called, what inputs were taken, what outputs were expected. This is what we'll be talking about in the upcoming session. And now we come to the end of it. We'll take some questions and get back to you.